What if you had a scientist who never sleeps, one that could read every single research paper ever written and then come up with its own ideas for new experiments? Now, that sounds like something straight out of a sci-fi movie, right? Well, it's not anymore. Today, we're talking about a massive shift in how science actually gets done. We're moving past AI as just another tool and into the era of AI as a true partner, an autonomous scientist. So here's our game plan. First, we're going to tackle what's called the discovery dilemma, the big problem that got this whole thing started. Then we'll make this new kind of autonomous scientist. After that, we'll dive into the mind-blowing discoveries already being made at machine speed. And finally, we'll explore what this new human-AI frontier really means for all of us. Okay, so first things first, why do we even need this? Well, to get it, you have to understand that in a lot of ways, modern science is in a desperate race against the clock. And this quote from Argonne National Lab, man, it just hits you, right? It perfectly spells out the bottleneck we're facing. For some of our biggest challenges, whether it's medicine or creating new materials, the old way of doing things is just, well, it's too slow. And it's not just about speed, it's the sheer volume of information. We're creating knowledge so fast that researchers are literally drowning in it. This creates these things called intellectual silos, where an expert in one area has absolutely no way to keep up with breakthroughs in another. And the ironic part? This actually slows down innovation because the next huge discovery is probably sitting right there at the intersection of two different fields, a place no single human can really see anymore. Yeah, this slide, this really puts it all into perspective. The old way is like taking a slow, winding country road. It takes years, it's all manual, and it's limited by what one person or team can think of. But the AI-boosted way, that's a superhighway. We're talking about compressing years of work into weeks, or in some cases, even days. And let me be clear, this isn't just a small improvement. It's a complete game changer for the pace of science itself. Okay, so that's the problem. It's big, it's urgent. So what's the answer? Well, this is where things get really interesting. We're starting to see a whole new kind of AI emerge. And these aren't just tools, like a better microscope. Think of them more like collaborators. People are calling it the virtual postdoc. And the idea, while it sounds simple, is just wow. Imagine having a research partner that literally never gets tired, has already read everything, and can see connections across different fields that no human could possibly spot. And then it turns to you and says, hey, have you thought about looking into this? So let's look at a few of these new collaborators. First up, you have systems like RDR. Think of it as the ultimate research strategist. Its job is to scan the entire map of human knowledge, find the blank spots, and say, okay, given everything we already know, that right there is the most promising place to dig next. Then you've got the next level up. These are AIs that don't just follow the rules, they invent new ones. They use something called meta-learning, which is basically a fancy way of saying they learn how to learn better. And they can autonomously discover brand new algorithms, totally new ways of thinking that are often way more efficient than anything a human has designed. Kind of mind-bending, right? And maybe the most revolutionary of all are systems like SEAL. You see, most AIs today have a big problem. Their knowledge is static. It's a frozen snapshot in time. SEAL tackles that head-on. It can continuously learn from new experiences, updating its own knowledge base without needing a total reboot. It's an AI that actually gets smarter all on its own. So, okay, we've seen the theory. We've got these strategists, these inventors, these self-improvers. It all sounds amazing. But the real question is, does it actually work? What are these things really discovering? Let's move from the theory to the reality. Let's look at a fantastic real-world example called Cosmos. The best way to think about it is like an AI project manager. A human scientist gives it a big, high-level goal, like, hey, go figure out what drives aging in this dataset. And then Cosmos just takes over. It assembles its own team of specialized AI agents and coordinates the entire research project, all by itself. So how did it do? Well, the results are pretty incredible. They brought in independent human experts to fact-check what Cosmos came up with, and they found that its scientific statements were accurate almost 80% of the time. That's really, really impressive. But this chart is super interesting because it shows you exactly where the system shines and where it, well, still needs us. When it comes to just pure data analysis, crunching the numbers, it's an absolute beast. But when it comes to the more subtle job of interpreting what that data means, of synthesizing a bigger story, that's where human expertise is still absolutely crucial. But make no mistake, Cosmos is already making huge, tangible contributions. I mean, check this out. It reproduced an unpublished scientific finding with near-perfect accuracy. It autonomously invented a whole new method for genetic analysis. And get this, it made a brand new discovery about a cellular pathway linked to early Alzheimer's disease, a finding the human researchers hadn't even spotted themselves. And these are the system's own words. It's not just spitting out data, it's weaving it into a real, testable hypothesis. It's talking about a pro-phagocytic access, which in plain English is basically a signal telling the body's cleanup crew to go remove specific brain cells. Cosmos proposed that this process is a key event in early Alzheimer's. That's a massive, actionable idea that came straight from the AI. So when you hear all this, you might be thinking, okay, are human scientists about to be out of a job? Is their role getting smaller? Well, everything we're seeing suggests the exact opposite is true. This whole revolution isn't about replacement. The key word here is amplification. You know, the new dividing line isn't going to be humans versus AI. It's going to be the scientists who use AI versus the ones who don't. The focus shifts from doing all the tedious work to guiding the work. The human role actually gets an upgrade. It becomes way more strategic. You become the architect of the whole process, designing the AI agents, asking the big questions, setting the ethical boundaries, and most importantly, making sense of the complex and sometimes totally non-intuitive discoveries that the AI uncovers. So you can start to see how this all clicks together into this incredible virtuous cycle. An AI strategist identifies a research gap. An AI inventor creates the perfect method for the job. An AI agent goes and does the work. And a self-learning AI integrates the results, making the whole system even smarter for the next go-around. Now, let's be real, this future isn't a done deal. There are some massive hurdles ahead. There's a deep technical problem called the stability-plasticity dilemma. Basically, how do you teach an AI new things without it catastrophically forgetting the old stuff? Then there's the huge safety question. As these systems self-improve, how do we make absolutely sure their goals stay aligned with ours? And finally, there's this subtle idea of scientific taste, teaching a machine to know the difference between something that's just statistically significant and something that's actually valuable. And this all leaves us with one final profound thought. As our machines get this good at finding the answers, maybe our greatest challenge and our most important human skill will be learning what new questions we should be asking in the first place. In this new era, the quality of our curiosity might just define the future of discovery.